For this problem, we want to list all the rational numbers in this set. Remember that rational numbers are any number that can be written in fraction form. So of course any number that's already a fraction would be a rational number, but also any other number that can be written as a fraction. For example, -7 could be expressed as -7/1. So -7 is a rational number. Since -4/5 is already written in fraction form, -4/5 is also a rational number. 0 could be expressed as 0 over any constant, or 0/1, for example. So 0 is also a rational number. 0.25 is actually expressed as 25/100ths, and that means it can be written as 25/100 and also reduced to a lower fraction. And so what that means is that 0.25 is also a rational number because any decimal that ends can be expressed in fraction form. Square root of 3 is not a perfect square, and therefore if we were to try to take the square root of 3, we'd see that it's a decimal that goes on infinitely without a repeating pattern. Therefore square root of 3 is not a rational number. Whereas square root of 4 can be expressed as 2, because 2 times 2 is 4. So because the square root of 4 is 2, and 2 can be expressed as 2/1, the square root of 4 is a rational number. 22/7 is again already in the form of a fraction. Pi is a decimal, but again it goes on infinitely with no repeating pattern, and therefore pi is not a rational number. So these would be the elements of the set that are rational numbers.